This is MATHguide.com, and my name is Mark Karadimos. Greetings, pre-calculus students. Today is your e-learning day. Grab your notes, which looks like this, and let's get started. At the top of your notes, you can see that there are 3 problems. Determine which, if any, are arithmetic. Press pause. When you're done, press play. Well, if it's arithmetic, it has the same common difference no matter which 2 consecutive terms you grab. So if we take a look at sequence A, if we take 5 minus 1, we get 4. If we get 9 minus 5, we get 4. Okay, so no matter which 2 consecutive terms we get the same. So therefore, we say the common difference is 4. Let's take a look at the second one. So the second sequence, if I take 4 minus 1, I get 3. If I take 9 minus 4, I get 5. Okay, so since these 2 numbers have different differences, there is no common difference, therefore it's not arithmetic. Well, let's take a look at the last one. So let's take x minus 4x. That's negative 3x. Okay, let's take let's take the next 2. Negative 2x minus x. It's negative 3x. And you can see that that is common throughout all of them. If I subtract 3x from one term, I'm going to get the following term. Subtract 3x, I get negative 8x in there. So, yep, that is arithmetic. So we have arithmetic, non-arithmetic, arithmetic. So let's take a look at this SAT question. Jessica opened a bank account that earned 2% interest compounded annually. Her initial deposit was $100, and she used the expression 100 times x to the t to find the value of her account after t years. What is the value of x in the expression? Well, the only number for x that makes sense, because you can see that we have already used time, right? We've got t for time. We've got $100 as the initial deposit. What we have not yet accounted for was the 2%. So if you know anything about percents, you know that 2% stands for 0.02. So if you look at the geometric sequence, the geometric sequence consists of a number, and you multiply it by what's called a common ratio to get the next term, called r. R is the common ratio. So if I take a times r, I get ar. That's the second term. If I get ar times r, I get ar squared. There's the third term. Ar squared times r, I get ar cubed, and so on. A sub 1 is the initial term, or otherwise known as the first term. Sometimes they use the word initial, the initial term. Okay, an is the first. No, it's the nth term. All right, so how do you get the recursive rule? Now, a recursive rule means if you start with any term, you multiply by r, you get the next term in the series. Sorry, sequence. Okay, so r is still the common ratio. A sub n, well, let's see. A sub n is the nth term. And a sub n minus 1, we would say that is the n minus 1th term. So the best way to think about this is the explicit rule is like a, it's like you could go from, if you've got an album and it's all on digital, you could go jump to whichever song you want on it. That's the explicit rule. I could jump to any song that's on your digital album. If you're talking about a recursive rule are like 8-track tapes or cassette tapes. You have to run through all the songs. You got to fast forward through every song. Got to go through the first song, through the second song, through the third song, through the fourth song to get to the fifth song. Okay, so you have to keep going through successive terms using the recursive rule. Whereas the explicit rule, you can zip right to the term you want. So the first thing you should do when you're trying these problems is to identify what you're given. Okay, so I know that if I've got these numbers in the sequence, I'm trying to find the 10th term. And I got to write a recursive rule. So the first thing I do is I notice that that number right there is our first number. That's 9. I want to figure out what's the common ratio. If I take 18 divided by 9, I get 2. If I take 36 divided by 18, I get 2. You could see that 2 must be the common ratio. Okay, so the formula to determine this, in other words, I'm using the explicit rule, is this one. You take the first term times r to the n minus 1. Okay, so we know a few things. We know we want the 10th term. I know the first term is 9. I know the common ratio is 2. And since n is 10, I take 10 minus 1 for the power. So I simply have to plug this into a calculator to get the 10th term. And it's 4608. Okay, there you go. So let's talk about the explicit rule. The explicit rule is a sub n. Let's get the first term. The first term is 9. Let's multiply that times the common ratio, r, except we know the common ratio is 2, and we know the n minus 1 power. So there you go. There's our formula for the explicit rule. Okay, what does the formula look like for the recursive rule? So I'm going to put that over here. Okay, so the recursive rule looks like this. Okay, so you have a sub n equals a sub n minus 1 times the common ratio. And we know the common ratio is 2. Now sometimes when people write this, they do put the 2 first. And there you go. There's your recursive rule. On to the next problem. Alright, so the first thing we need to do is identify what we're given. So here, this number right there, that is our first number in the sequence. Now let's figure out what the r is. If you were to take 0.7 divided by 7, you're going to get 0.1. And that would happen too if I took any two consecutive numbers, the right number divided by a left number. I'm going to get 0.1. That is the common ratio, and that's how you find it. Take any two consecutive numbers, right number divided by the left number. Okay, so what do I want to do? I want to find the 10th term. Okay, well, the formula is, for the explicit rule right here, the formula is this. You take a sub n equals a sub 1 times r to the n minus 1. Now, we already know what the first number is. Okay, so I know our first number is 7, and I know the common ratio is 0.1. There you go. There's our explicit rule. We're going to use this explicit rule to get the 10th term. Okay, so how do you do that? Well, we're going to substitute n for 10. Now, we just throw this into a calculator to get an answer. So the calculator gives me some strange looking number. Okay, that is scientific notation. It's a very tiny number. It really means 7 times 10 to the negative 9th. All right, how do you write that answer? Okay, that means there's a 7, right? And normally here's the decimal to the right of it, but I'm going to move the decimal 9 places to the left. So if I move the decimal there, that's 1 place, 2 places, 3, 4, 5, 6, 7, 8, 9 places. There you go. 6, 7, 8, 9. Yep, just double checking. All right, there's our 10th term. Now let's write a recursive rule. The recursive rule says if you take the n-1 term, multiply it by the common ratio, you get the nth term. Again, I'm going to put that common ratio first. There you go. There's your recursive rule right there. On to the next problem. All right, imagine if you had 5 blanks. This is our first term, second, third term, fourth term, fifth term. All right, well, they give us the third term, they give us the fifth term. What we're trying to do is figure out the first term. All right, well, let's think like a geometric sequence. In order to go from one term to the next, you got to multiply by the common ratio, r. So if I multiply by r, I can get to the fourth term. If I multiply by r again, I get to the fifth term. You'll notice that the only way I could go from the third term to the fifth term is to multiply by r twice. Okay, so what does that look like? It says a3 times r is equal to the fifth term. Okay, so let's just plug in what we know. R times r is r squared. And I've got a to the fifth, which is 9/2. All right, let's do some algebra. Let's solve for the common ratio. So to get rid of a half, I'm going to multiply both sides by 2/1. The half and the 2 cancel. On the right side, the 2's cancel. The only way to get rid of square, well, in other words, the inverse, is to take the square root. So r is equal to 3. Well, you'd be wrong because there's a plus or minus when you take the square root, which a lot of people like to forget about. All right, so we don't know if the common ratio is positive or negative. It actually, either case works here. Okay, now let's imagine that we're going to try to now find the a sub 1. Okay, so to go from a sub 1 to a sub 2, I got to multiply by r. I got to multiply by another r to get to a sub 3. So similar to the first part of this problem, if I take a sub 1 times r, that's r squared, we get 1/2. Okay, but we know what r is. R is either 3 or it's -3. If 3 squared is 9, -3 squared is 9. It doesn't matter. I know that r squared, whether r is positive or -3, r squared is going to be 9. Okay, so I know that this is really a sub 1 times 9. Okay, how do we get rid of 9? We're going to multiply by its reciprocal, 1/9. So the 9 and the 1/9, that is, cancel, and you get 1/18. And there you go. There's the first term, and that's what we were looking for, the first term. On to the next problem. So I will be finishing with the notes in a moment. I just want to inform you that in the description of this video, if you will check that out, you're going to find that I'm going to place a link in there that sends you to a geometric sequences quiz master on MATHguide. And this will check to see if you can come up with the explicit rule. If you could find the explicit rule for a few problems, then you really do get this. And you're understanding how to get the common ratio, and at least you'll understand how to get the formula. All right, let's get back to the notes. Okay, similar to the last problem, we were given some information. In other words, we're given the 5th and the 8th terms. So again, I'm going to do 1, 2, 3, 4, 5, right? So we know the 5th term is 1920. 6th, 7th, 8. Here's the 8th term, which we know is 30. They're asking us to find the first term. Okay, now this is how you do the problem when you're trying to really understand all the steps to these problems. It's not so bad to do because you could actually make blanks for 8 or 5 terms. Okay, so this makes it a little bit easier to do these types of problems. All right, well, if I'm at the 5th term, I have to multiply by r to get to the 6th term, multiply by r to get to the 7th term, multiply by r again to get to the 8th term. So basically I'm saying is I have to take 1920 times r times r times r to get 30. Okay, so how do I get these r's alone? Well, maybe I should first write this as r cubed. Now I could get rid of the 1920, right? So if I'm multiplying, well, we know the inverse is to divide. That is the inverse operation. Okay, so I get r cubed equals 30 over 1920. Okay, now what's the inverse of cubing? The inverse of cubing is cube rooting. Do you take plus minus with an odd root? You do not. Only with even roots. All right, so we now know that r is going to be the cube root, which I'm going to toss in the calculator. And the answer is 1/4. All right. Now remember, our goal is to get a sub 1. Okay, so now similarly we're going to think, how do I go from a sub 1 to a sub 5? Well, I have to multiply once to get to the 2nd term, another r to get to the 3rd term, another r to get to the 4th, and finally another r to get to the 5th. Okay, so what does that really mean? It means that I have to take a sub 1 times 1, 2, 3, 4, right? 1, 2, 3, 4, yep. 4 r's, that's r to the 4th, right? R times r times r times r is r to the 4th, is equal to 1920. Now remember, we already do know what r is. R is 1/4. So how do we get a1 alone? Well, if I'm multiplying by 1/4 to the 4th power, that's exactly what we're going to divide by, 1/4 to the 4th. Okay, so again, we shove this into a calculator. All right, so the answer is, so a1 is 49, 15, 20. A huge number. All right, so it's asking us to figure out how many ants are there after 6 years. Well, they tell us that the initial population is 160 ants. They say how many ants are we going to have after 6 years. They also give us this rate, 8%. 8% is 0.08. Now, if you think this is the R, the common ratio, you'd be wrong. Okay, why is that? They're saying that it's growing. Now, if you remember, it's growing at a rate of 8%. If you remember from exponential equations and exponential functions, if your common ratio, or in other words, in that parlance, is that if your base is less than 1, it's decreasing. If your base is larger than 1, it's increasing. All right, what does that mean? That means you can't forget about the initial amount. Your starting amount is 1, right? That's how much you start with. 1 times 160 is 1. Okay, so I don't want an 8% rate. I want 108%. Therefore, it'll be increasing, right? So it'll be a 1.08. There's your rate, 1.08. Yeah, try doing this with 0.08. You will not get growth. You'll get decline. Okay, so anyway, here's another issue to deal with. If you're dealing with these ants and you want to figure out how many ants you're going to have after 6 years, you got to really think about this part too. Okay, you're starting over here with 160. That's your starting. If I find the next, which is A2, that's only 1 year of growth. I don't want 1 year growth, 2 years, 3 years, 4 years, 5 years. I want 6 years. Okay, so you got that. At the end of A2, that'll be 1 year growth. 2 years, 3 years, 4 years, 5 years, and then finally 6 years. See, there's 1, 2, 3, 4, 5, 6 years have passed. Yes, I want A sub 7. Okay, so how do you do this problem? You now realize that your formula is going to look like the first term times the rate to the n minus 1 power. Now we just figured out that we wanted the A sub 7. Okay, so that means I'm going to put 160, 1.08 to the 7 minus 1. Of course, that's 6th power. Okay, so we're going to throw that into a calculator to get an answer. So the calculator reports this, 253.89989, blah, 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 blah. Of course, you can't have a decimal number of ants. It doesn't make any sense. You're not going to round up. You're only going to take as many ants as we have. So we're going to approximate this to 253 ants. And that would be 6 years have passed. All right, let's go on to our last problem. Okay, so they give us a geometric sequence. They tell us the first term. How do you get the common ratio? If you divide, 3 divided by 1, you get 3. 27 divided by 9 is 3. 9 divided by 3 is 3. If you divide any two successive terms, you get 3. Okay, now let's get an explicit formula. So this is the way the explicit formula works, right? Just pull this right off your notes. So you take your first term, you multiply it by your common ratio to the n minus 1. When you multiply by 1, it doesn't really change anything. Okay, so I know this is how I arrive at any nth term. Now, I do know that I want this nth term to be greater than 7,000. Okay, well, let's figure out when it's equal to 7,000. All right, how do I do that? Well, if you remember anything from dealing with logarithms, which we had to have dealt with logarithms before we get to this point in the curriculum, the only way to deal with a variable exponent is to take the logarithm of both sides. So you land up taking the log of both sides, and you're asking yourself, why? Why is he taking the log? Because there's a property of logs that says you can move the power out in front, which is the most powerful log property there is. If you do that, you get this. How do I get the n minus 1 alone? Well, if I'm multiplying, the only way to do that is to divide. So you're going to divide both sides by the log of 3. So you get n minus 1 equals log of 7,000 divided by log of 3. I don't want n minus 1, I want n. So the inverse of subtracting 1 is to add 1. So you take this log of 7,000 over log of 3 and add 1 to it. Now you throw this into a calculator to get the result. So the calculator says 9.0589. I'm going to round that to 9. Now this makes no sense for the scenario that we're dealing with. You can't have a 9.05 ninth term. It doesn't make any sense. You either have an 8th term, a 9th term, a 10th term, but not a decimal number of terms. So this is the value for n that makes it exactly 7. But they want us to figure out when does it first exceed. So the 9th term would be too low. So that means if the 9th term is too low, the 10th term would be over 7,000. And there's your answer. It has to be the 10th term. Well, hopefully you feel comfortable after watching this MATHguide demonstration of your notes that you'll go back to MATHguide and check out our interactive quizzes, our numerous videos, and of course hundreds of lessons. Yep, that's MATHguide.com. Take care and good luck with all your pre-calculus endeavors.